Hello and welcome to yet another video of Cornerstones of Math. If you have learned basic coordinate geometry, many of you might also have learned this famous formula to calculate the distance between a point and a line. The distance from point x0, y0 to the line ax plus by plus c equals 0 is given by absolute value of ax0 plus by0 plus c divided by square root of a square plus b squared. This is indeed a useful formula, but students may sometimes forget this basic formula if they focus on more advanced math such as conic sections and calculus. In this case, is there another way to find this distance d? Well, there are actually more than one method to calculate the distance, and I will show you two methods to do that as the first part of this video. The first method is simultaneous equations method, and the second method is vector method. These are the methods that are commonly used to derive this formula, so they are definitely worth our attention. However, I'm not trying to argue that you don't need to memorize this formula. Actually, I will present you another sample problem just to explain how things can get really complicated if you do not use the formula, and why it is absolutely necessary that you memorize this formula. Alright, now let's move on to the first part. As for the first sample problem, we attempt to find the distance d between point P given as 4, 5 and line L given as 3x plus 4y minus 2 equals 0, but without applying the formula. Actually, if you use the formula, you can solve this problem in less than a minute, but I want to show you other methods here. First, let's take a look at the simultaneous equations method. The strategy is as follows. Let Q be the intersection point between line L and the perpendicular line drawn from point P to line L. If we can find the coordinates of this intersection point Q, then we can calculate distance d by calculating the length of the line segment PQ using the most basic distance between two points formula. Here, point Q can be found by first obtaining the equation of the perpendicular line PQ, and then solving the simultaneous equations using the equations of these two lines, each representing line PQ and line L. Now let's work with actual numbers. So first, finding the equation of line PQ. We know that line PQ passes point P, which is 4, 5, so we only need a slope to find its equation. If we take a look at line L, we know that line L has the slope of negative 3 over 4. This means that the slope of line PQ must be 4 over 3 because the product of these two slopes must be negative 1 when two lines are perpendicular. So by using point 4, 5 and slope 4 over 3, the equation of line PQ is y minus 5 equals 4 over 3 times x minus 4, which rearranges to 4x minus 3y minus 1 equals 0. So now that we found the equation of line PQ, it is time to solve the simultaneous equations and find the coordinates of intersection point Q. We have to use this equation and solve for x and y. This is just a simple linear system with two unknown variables, so I will skip the details of solving the equations and just present you the root, which is x equals 2 over 5 and y equals 1 over 5. So this point Q is 2 over 5, 1 over 5. And once point Q is found, finding distance d is easy. You just use the formula for the distance between two points using these points P and Q. So we have d equals square root of 4 minus 2 over 5 squared plus 5 minus 1 over 5 squared, which you can compute to obtain 6. The same answer as the one obtained by formula. And now let's take a look at the second method, the vector method. This method is actually quite similar to the first method in the sense that this intersection point Q is also involved here, but this time we do everything using vectors. In order to use the vector method, first you must have this understanding that points are essentially vectors, more specifically position vectors. Let us use this given point P as an example. We can think of this point P as a position vector OP, where this O is a reference point 0, 0. Alright, then how do we obtain the equation of line PQ using vectors? Well, in order to answer this question, let us think about what we do when we find the equation of a line. First, let us consider this point capital X, which represents the arbitrary point on line PQ. Here, the most generally used variables lowercase x and y indicate its coordinates. In this case, finding the equation of line PQ means finding the equation or relation that variables x and y satisfy. In terms of vectors, the arbitrary point on the red line can be expressed as a position vector OX. Therefore, finding the equation of the line means finding the equation that vector OX satisfies. The equation expressed by using vectors. Let's see how it's done in this case. In order to obtain the equation of line PQ, we first need its direction vector v that is parallel to the line. And we can find this direction vector v using this direction vector u, which is the direction vector of given line L. We can find vector u from the slope of line L, which is -3/4. This means that as x increases by 4, y decreases by 3, so the direction vector u is given as 4, -3. Then we can find the direction vector v from the fact that line PQ is perpendicular to line L. You can either use this slope 4/3 to find that vector v is given as 3, 4, or you can use the fact that since two vectors u and v are perpendicular, their dot product must be 0, and the simplest example of vector v satisfying such relation is 3, 4. Using this, an arbitrary position vector OX to line PQ can be expressed as follows. First, point vector OP, which is a fixed point vector by the way, then plus vector PX, which is a varying vector depending on the position of x. Here, vector PX is parallel to the direction vector v, so it can be written as Px equals t times vector v, where t is a real number. So we have vector Ox equals vector Op plus t times vector v, which is called the vector equation of line PQ. If we rewrite this expression using coordinates, we have x, y equals 4, 5 plus t times vector 3, 4. So 4 plus 3t, 5 plus 4t, which can be also written in this format. This is the parametric equation of line PQ, where x and y are given as functions of parameter t. Using this, let us think about how we can find the intersection point Q. When our arbitrary point x coincides with Q, point x not only lies on line PQ, but also on line L. Therefore, point x, y, which is given like this, must satisfy the equation of line L. So we have 3 times 4 plus 3t plus 4 times 5 plus 4t minus 2 equals 0, which simplifies to 25t plus 30 equals 0. So we have t equals -6/5. So by substituting this value of t at here, we can find the coordinates of point Q and then calculate the distance from point P to line L. But actually, we don't even need to find the intersection point Q in order to find the distance d. Because you see, d is the magnitude of vector PQ, which I will denote using the absolute value notation. And this vector PQ is equal to t times vector v when t has this value. So we have the magnitude of vector TV which equals the magnitude of real number t and the magnitude of vector v. So we have 6 over 5 times the magnitude of vector v is square root of 3 squared plus 4 squared. So we have 6 over 5 times 5, which gives 6. So we have arrived at the same answer. But I am not done here. Just as I said at the beginning of this video, the main claim of this video is that you must memorize this formula because it is that useful. The previous two methods may not have seemed complicated, but that's because in the previous problem, the unknown variable was on the left-hand side and everything on the right-hand side was given. But in many cases, we encounter a problem where d is given and one of the variables on the right-hand side is unknown. In that case, not using the formula often results in calculations that are so complicated that it is absolutely beneficial if you just apply the formula. Let's examine this claim more closely by solving this sample problem. Here, the distance between point 2, 1 and line 3x minus 4y plus c equals 0 is given as 1. And we have to find the value of c, which is actually still one of the easiest distance problems, by the way. If we just use the formula, then this one is no problem at all. So we have distance 1 equals absolute value of 3 times 2 minus 4 times 1 plus c divided by square root of 3 squared plus 4 squared. And since this denominator is 5, we have absolute value of 2 plus c equals 5. And this means that 2 plus c is equal to either 5 or negative 5. So we have c equals 3 or negative 7. Notice that we have two possible values for c, meaning that we have two possible lines, one right here and one right here. But if you try to solve the same problem with simultaneous equations method, things get complicated. I mean, the first part where we obtain the equation of perpendicular line PQ is not that bad. But if we try to solve simultaneous equations to find the coordinates of point Q, the expressions become messy due to the unknown variable c. And when it comes to the part where we set up the equation using the given distance d and solve it to find c, you'll notice that the equation is now much complicated compared to the formula method. And if you use the vector method, in this case it actually yields an equation that is quite similar to the case of formula method, but still you have to take many steps in order to get there. And this is just the beginning of the bigger problems. Consider this problem, where now we have an unknown variable k as an x-coordinate of the point, and we have to find the value of k using the given distance condition. If you use the formula, you'll notice that the equation you need to solve and the overall process remains rather simple. Oh, and by the way, we also have two answers here, which is quite obvious if you look at the figure. But again, if you use the simultaneous equations method, then we have this lengthy solution with this much ugly looking equation. And if you use the vector method, well, the equation is still kinda nice, but you must know how to handle vectors in order to use this method. The real highlight is when one of the coefficients of x and y is given as unknown, like this one where we have to find the value of this a. If you use the formula, it seems that now we obtained a tricky equation since it contains a in both absolute value and radical. But this is still very simple equation, because we can use the trick called squaring both sides and remove both absolute value and the radical at the same time. Then the equation simplifies to a simple quadratic equation which we can easily solve. And you know the drill, two answers, two possible lines. And if you use the simultaneous equations on this one, even solving the simultaneous equations themselves is not easy, and after that, you will encounter undoubtedly the most complicated equation in this entire video. And as for the vector method, now you have understood. Same equation as the formula method, but we have to go a long way to actually get there. So the conclusion of this video is, the distance from a point to a line formula really makes things much simpler when solving distance-related problems, So you must memorize this formula and never forget it. And that's all for today's video. Thank you for watching. Please don't forget to hit that like and subscribe buttons, and I will see you in another video.